Hi everyone. Today we are going to discuss second unit of embedded system. In this unit, we are going to discuss some important concepts of embedded systems. Now I am going to explain the sensors and actuators part of the second unit. In this unit, we are going to get 10 marks questions on this sensors and actuators. This is an important concept in this unit, and here we'll discuss what is meant by sensors first. Next we'll discuss what is meant by actuators, some examples for sensors and actuators. The sensors, already I have told some concepts regarding sensors and actuators in last class, in last video. Sensors that converts the one energy from one form to another form for any measurement or control purpose. Actuators account to the processing of core of embedded system. You will get the outputs. Those outputs is nothing but actuators. The actuator will going to take the output of particular applications that which converts those signals into corresponding physical actions act as output device. Here we'll study which are those inputs and outputs in the systems, that's known as input and output subsystems. Inputs is nothing but sensors, outputs is nothing but which is going to control by actuators. The first one is LED. LED is output device. Already you know, the LED means light emitting diodes. If you want to know the some status of the particular applications, the LED is going to give the status as an on or off status. So if you want to know some system is on state or off state, in those cases you can use LED as a output device to know the status of your applications. For example, power status. If you make it power on, that is going to denoted by using the LED that is blinking. It becomes on state. It become a on. That is, if you are using a red LED, it is going to give the on state in terms of red. Like that, you can use different types of LEDs to know the status. And it has a PN junction diodes, and it has one terminal is anode, that is anode to positive terminal. Another terminal is cathode to the negative terminals. And here you can use the resistors in the series to limit the current which is flow from the supply which is given to the LEDs. Second device is 7-segment LED display. Here it is light emitting diode, but it is display. It is also output device. Here you can display alphanumeric characters. For example, in bikes you have speedometers. Nowadays you can see the digital speedometers that is going to display the speed in terms of numbers. That numbers is going to nothing but alphanumeric characters. You can get the speed in terms of numbers. Sometimes you want to display some messages in terms of letters, so both can achieved by using the 7-segment LED display. Here you can see that it has total 8 LEDs, that is having A to G segments. It has 2 types of configuration. You can use 7-segment LED display in 2 types of structure. You can connect in 2 ways, that is by using common anode and common cathode. These are 2 configurations are available, and it is used for low cost applications. Wherever you can have the applications having low cost, in those cases you can use the output device as a 7-segment LED display. Next is optocoupler. Optocoupler is mainly having used for to isolate two parts of a circuits. For example, optocoupler mainly it is used for suppressing the interference in data communications or high voltage suppressions. Like that, you can separate out the 2 parts. It contains mainly 2 parts like LED. One part is LED, another part is phototransistor in a single package. It can be used as input and output circuits. In both sides you can use optocouplers to separate out the particular circuits from in high voltage separations or data communications. Like that you can use the optocouplers. Next is stepper motor. Nowadays you can see the different types of applications like robotic controls or electron products, or you can use printers, scanners. There if you want to feed the paper mechanism, this is going to achieved by using the stepper motors. Stepper motor is nothing but it is a electromechanical device which generates discrete displacement in response to the DC electrical signals. According to the DC electric signals, there will be some amount of displacement is going to happens in stepper motors. So there are two types of stepper motor, that is it has two phase, one is unipolar, another is bipolar. So in unipolar it contains two windings per page, and direction of rotation of the stepper motor you can change it by changing the direction of current. So stepper motor can rotate in clockwise direction as well as anti-clockwise directions. So you can change the direction of current, that changes the stepper motor directions. The direction in one the current in one direction flows through the one coil in opposite direction through the other coils. Bipolar, there is contains single winding per page, that's why it is called as bipolar. Per page a single winding. For reversing the motor rotations, the current flow, again it is same thing here also, you have to change the direction of current, that's how they are told here. The current flow through the winding is reversed. Stepping of the stepper motor can be implemented by changing the sequence of activation of the stator windings. You have to make the windings makes active. By making the particular windings active, you can get the different stepping of the stepper motors. That is, what are the different stepping motors, you can understand by using these tables. One is full step, another is wave steps. Both for we have shown the how to get the full step stepping modes and wave step stepping modes. Here 4 steps you will get for the full step as well as in wave step, but to give the energy for the phases it will be different for both full step and wave step. In full step both phase going to get the energy and after it becomes active simultaneously, but that is not case in wave step. Only one phase becomes active at a time. There are no two phases will not get active like a full step. You can see the tables, coil A and coil B both are get high and another coil C and coil D becomes low. So two coils, that means it is both phase it becomes get the energy or becomes energized simultaneously, that is gives a full step rotation of the stepper motor. Here wave step only one phase is going to get the current, that is high means, and remaining coils are become slow, which is are going to connect a ground, that high it is going to half step or wave step. Only one coil going to get energized at a time. Next, half step, combination of wave and full step. That is I told half step is another, it is combination of both wave and full, so that's why it is going to get 8 combinations. Because of that it is going to get the depends on the combinations, the alternative coils are going to get the energy, sometimes both coils and sometimes one coil or one phase is going to get the energy. According to that they will get the half step. Next, relay. Already you have heard this word relay. In most of the applications relay is used for output device. So relay is known as electromechanical device. It contains a relay coil made up of the insulated wire on a metal core and a metal armature with one or more contacts. If you see the diagrams, you will understand the every output device structures. Already I have given the diagrams. So here I am going to explaining how their structure will be there, how they are going to work. And next, if you applied voltage to the relay coils, the current going to start flow into the armatures, the metal core, and it is going to generates the magnetic field which attracts by the metal armature, that is going to makes to move the contacts toward the contact point, then it is going to generate the current according to the magnetic field is going to generate by the armature core. Here you have different types of configurations. You can use different types of relay. Example, single pole single throw normally open, or single pole single throw normally closed, or single pole double throw. Like that you will get the different types of configurations in a relay. Next, piezo buzzer. Piezo buzzer is a piezoelectric device to generate the different tunes. So for some of the applications, for example, buzzers in the washing machines, or in calling bells, and in automobiles and in bikes, you will get the different types of ringing tones. After generating the particular current, it is going to generate different tunes. How it is going to happens? It is going to happens by using the piezo buzzers in the systems. In embedded systems, they are going to use to generate different tones. It contains mainly piezoelectric diaphragm, which produce the sound in response to the voltage. According to the level of the voltages, different voltages in the diaphragm, that is going to generate different levels of tones. And some of the piezo buzzers are self-driving, some of external driving. So in self-driving means there are predefined tones already inbuilt, so you won't get different levels of tones in self-driving piezo buzzer buttons. There are always, you want to get same ringing tones always in self-driving piezo buzzers, but in external driving you will get the different types of tones in external drivings. Next, push button switch. It is an input device. Till now we have discussed regarding the output device. This is, we will discuss input device. Here, push button switch, you are going to use the different types of switch to make or push to break. Normally closed or normally open push button switch. You can see the different applications. They are going to the buttons. That buttons, you can say switches. It is, some of switch are used to break the circuit connections. After that you will get the output. Some switches are makes a circuit connection to get the output. This is used to generate a momentary pulse. Once you press the particular switch, it is going to produce one momentary pulse. That is most of case in embedded systems or embedded applications. You can use this push button switch to make some operations like a reset operations, off operations, or on operations, like that. It is to make a system start. We can use this push button switch. And here you can see that depends on the way in which push button is interfaced to the controller, it can generate either high or low pulses. Some of the switch are active low pins, or some of switch are active high pins. Depends on the programmer can use the different push button switch, or high push button switch, or low push button switch to generate the different types of pulses, high or low pulses. Next, another input device is keyboard. Nowadays you can see, so in some of the embedded systems come up with the input keyboards, inbuilt keyboards to enter some numbers, to enter some special characters, or to enter some letters for as an input to process the application and to get the output according to that one. So for that you are going to use a keyboard. Keyboard can use push button switch. Already it is a number of combination of different switches or push buttons, but it is a wastage of port pins. You have to connect every switch to the port pin, so it is going to consume more number of port pins. So they are going to use a matrix keyboard, which reduces the number of interface connections. Instead of connecting individual connection to the individual pins, they are use the some combination configuration like a matrix keyboard. It is combination of 4x4 or 8x8, like that. They are going to use so many number of pins, so many number of switches for connecting less number of ports using this one. Here you can use detecting the key press using the scanning technique. They are going to use the technique, scanning technique. Using that scanning technique, particular key, which key is pressed or not pressed, they are going to detect. By using this technique, a particular row and particular column is going to detect whether the key is pressed or not pressed, and it is also going to prevent demons issues completely. And there are different techniques, software technique and hardware techniques to implement keys read after D bounce delay. Next, to interact with the outside peripheral devices, there are going to use different PPI devices, peripheral interface devices, to extend the I/O capabilities of the processors. In a processor, if you are using processors, if you need any external devices, you want to communicate with the outside the IC, outside the board, if you want to communicate the devices which are connected to the processors, you have to use the intermediate devices, that is PPI, okay, peripheral interface devices. One of the best popular PPI is 8255. So it is supports 24 I/O pins, so which can be grouped into 8-bit parallel ports, port A, port B, port C. Like that, it provides the external again 24 I/O pins you can connect, and you can use those 24 I/O pins which are grouped into 8-bit parallel ports. That means each port having 8 bit in size. Like that, totally you have 3, so 8 into 3 it becomes 24. Like that, it is going to helps us to produce or helps us to communicate different peripheral devices with the processors. Next, how you are going to communicate? How you are going to communicate on board? Because if you take one embedded applications, and every board, if you consider, it has not only IC, that means now it doesn't have only microcontroller, microprocessor. It has so many things are connected to the central processing units. For example, it has a connection with the RAM, ROM, and input devices, output devices like LED, LCD, optocouplers. Then how you are going to communicate with those devices? And you are going to connect externally so many things, like you are connected printers, scanners, or serial IO ports, or memory you can connect. Those things how you are going to communicate. Those are, you can say that, communicate interface. So communicate interface broadly classified into onboard communication interface and external board communication interface. In onboard communication interface, you can say that first one, I2C or I2C bus, is known as inter-integrated circuit bus. It is synchronous bidirectional half duplex 2-wire serial interface bus. Okay, the synchronous, that means here bidirectional, it is both way direction, both way communications. Half duplex means you can communicate but not simultaneously, while transmission receiving is not happens, while receiving transmission not happens. That is known as half duplex. And it is synchronized. You have to synchronize the operations by sending the sync pulse, or you can have to send the serial clock. It has 2-wire serial interface. One is SCL and SDA, serial clock and serial data. That is known as SCL and SDA, both having synchronized. Many number of I2C device can be connected. You can n number of I2C device can be connected on board itself, not externally. And devices connected to the I2C can be act as a master and slave. Here one device should be master to control all slave device operations for serial data or serial clock, and master is going to generate the synchronization clock to start up the operations. And I2 bus has 3 different data buses with the different speeds of 100 kbps, 400 kbps, 3.4 mbps. Depending on speed, it is going to varies the communications. Next one is serial peripheral interface, that is shortly known as Spi bus. It is known as synchronous bidirectional full duplex 4-wire serial interface bus. It is same as I2C bus, but it is full duplex, but I2C is half duplex. And here you can get 4-wire serial interface bus. It is single master multi-slave system. That means one master which is connected to the n number of multi-slaves, n number of system you can connect in SPI. So it needs 4 signals if you want to make a communication with the SPI. Master out, here those 4 signal lines are master out slave in, master and slave out, serial clock, slave select. The 4 lines should be present if you want to make a communication with the SPI. Master device is responsible to generate the clock signals. It is same as I2C. Again, here master device is going to connect all, going to control all the operations. Master has to select which is the required slave device, which is need for communication, which slave has to select. That is, all these decisions going to taken by the master device. SPI works on the principle of shift registers. Master and slave device contains special shift registers for data to transmit or receive. Here they are going to use the registers to receive or transmit the data. And size of the shift register is device dependent. Normally it is 8 bits in size, multiple of 8s. Sometimes it is going to use a different combinations of 16, 32, like that. It completely depends on the devices. Compared to I2C, SPI is more suitable for transfer of data in streams. Limitation is it doesn't support for acknowledgement mechanism. That means after receiving or transmission, whether data is successfully transmitted or received, you won't get any information regarding that. So that is the only drawback of SPI. Next, universal asynchronous receiver transmitter. Short form, it is known as UART. It is asynchronous. Here there is no any synchronization for transmission of your data. Before transmission of data, you have to give some predefined agreements between devices. Here it won't generate any clocks. That is called as synchronization. Before start the operations in synchronize, they are going to produce, the master device is going to produce the clock signals. That is not going to happen in UART. So here before start of and after end of transmission, it is going to make some predefined agreements between the devices. For proper communications, the transmission line of a sending device should be connected to the receiving devices. And here it provides some handshaking signals which supports for controlling the serial data flow. As I told, it is asynchronous. To make your transmission and receiving should be proper. For that, both connected devices should be interchange some handshaking signals to know how before start the communication and after the end of the communication, it is going to send some signals like a before sending, it gives some start bits. After end of the communication, it is going to send some stop bits that indicates our communication is started now or communication ended now. Like that, it is going to send some start stop bits with the data. So it is nowadays most of the microprocessors are available with integrated the UART functionality. One wire interface is again asynchronous hard loop-like communication. It makes use of a single line called DQ for communication, follows the master-slave communication models like a I2C. And here it allows to power to be sent along the signal wire well. So here you can send the data as well as power also you can send it by using a single power line. That's why it is one wire interface. It supports single master and one or more slave device. Here you can connect more than one slave devices, and main a single device is act as one device act as a master to control all the operations of slaves, and every one wire device contains globally unique 64-bit ID stored within it for addressing. That means every device has a unique ID to identify and depends on the address of each slave devices that is controlled by the master. Communication over the one wire bus is divided into time slots of 60 microseconds. So every device is going to communicate with the masters over the time period of 60 microseconds. And finally is parallel interface. As you know, instead of having serial communication with the peripheral device or onboard communications, we can communicate by using the parallel. Parallelly, we can connect different I/O pins. This is the main concept used for the interfacing of memories, RAM and ROM. Like that, there parallel buses directly connected these buses, and directly we can access the address of those connected memories, and you can read or write the data to the memories using the different signals, and here you can connect different size of memories to the core of the systems. Next, after completion of onboard communications, you should know how communication happens outside the board. If you are connected different serial ports, if you are connected different parallel ports, if you are connected different peripheral devices, how you are going to send the data from the IC or from the board to the outside of board. Here you are going to use some different communication channels. First one, RS-232, or it's also known as RS-422. In some cases you are going to use RS-485. So different serial communication interfaces. In some application they are going to use RS-232. In some cases they are going to use RS-422. Some cases you can use RS-485. Depends on the increased speed of transmission. You can use different types of serial communications. And mainly this is developed by EIA, Electronic Industries Association, during the 1960. It is full duplex, wide connection, asynchronous, and it is serial communication interface. Here you can see that some concepts related to the serial interface. Logic 0 is represented with a voltage between 3 and 25. Logic 1 using voltage between -3 and -25. Logic 0 is known as space. Logic 1 is as a mark. This is a main concept you have to remember if you are doing the communication with the external by using RS-232. If you are sending different levels of logic, what is the meaning of that? Okay, if you are sending logic 0, it is going to send the voltage in the range of positive voltage 3 to 25. If you are sending logic 1, it means the voltage you are sending -3 to -25 voltage range. You are sending logic 0 known as space, logic 1 as a mark, and low pulses. It supports different baud rates up to 20 kbps. Still, these are popular in industry applications. In most of the industry applications, they are using RS-232 cables. Here, you support different types of connectors, different DB9, DB25. That means pin numbers. If you are using 9 pins of RS-232, it is known as DB9. If you are using 25 pins of RS-232, it is known as DB25. It supports point-to-point communications. It is mainly not suitable for multi-drop communications. Next, universal serial bus. Already you are using USBs. You are going to connect USB to systems to communicate and to transfer data, to store the data, and some of the USBs mainly used as a serial bus for data communications. Then how USB is going to used in the external communications? It is compared to RS-32, it is going to transmit data in packet format. And here, if you are connected the USB, it is mainly follows the star topology. That means USB host as a centers, one or more USB peripheral devices are connected to the center USB. That's why it is known as star topology. If you know the star structure, you will understand one device will be host at present in the center, and many USBs connected to that center USBs. It mainly improves the noise immunity. The noise is very less in this case communication, and its ability to supply the power to connected devices. And there are different types of USBs, mini USB, micro USB connectors are available. Depends on the applications, you can use different types of USBs, and it supports 4 different types of data transfer. How we are going to transfer data? You can transfer data in form of control, bulk, isochronous data, and interrupt transfer. These are 4 different ways to transfer the data. You can see that what is meant by control. It going to query, configure, and issue the commands to the USB device. In bulk, you can send a block of data instead of sending them individual bits of data to the device. Isochronous is mainly used for serial data communications and in real-time data communications, and it doesn't support for error checking and retransmissions. And finally, interrupt transfer for transmitting small amount of data compared to block of data. It is going to send some small amount of data which is larger than bulk transfer. Next, IEEE 1394 is known as FireWire. It is wired isochronous high-speed serial communication bus. It allows total 63 devices to be connected on the bus in tree topology, and it can support cable length of up to 15 feet. It is Serial communication, another type of serial communication. Here you can make point to point communication or point to multi point communications. This is another advantage, and it supports three types of connections: 4 pin, 6 pin or 9 pin, which operates data rate of 400 to 3200 Mbps per second. Mainly these IEEE 1394 is mainly used in the devices like digital cameras, camcorders for data transfer and storage. You can see the digital camera, the capturing the data, storing the data in the happens in different speeds. That it depends on the which type of IEEE 1394 you are using in your systems. And data rate is far higher than the USB. That is, you can say that that is 400 3200 megabits per second. Hardware implementation is costlier than but it is more costlier compared to USB. Infrared IRDA, it is serial half duplex and line of sight based wireless technology. Best example is your remote control of TV. There you are going to use the infrared, that is to communicate with the TV by using the remote control. That is, again, it is supports for point to point and point to multi point communications, and here range is limited. The communication range is 10 cm to 1 meter. It supports the data range again 9600 bits to 16 Mbps. Again, it has two ports. Physical link part is there, protocol part is there, popular for file exchange, data transfer in low cost devices. And Bluetooth, already you know, in most of laptops, mobiles having this facility. Bluetooth, it's a low power and short range. If you are having very less number of range, that is approximately range 30 feet and data rate up to 1 Mbps it supports. Within that speed you can transfer data between two devices. Mainly it is wireless technology for data and voice. It is just like an infrared structure. It has two parts, and each Bluetooth device has 48-bit unique identification number. That is, while pairing the two devices using Bluetooth technology, this number is very useful. It again supports for point to point and point to multi point communications. Here again one device acts as a master and another device it acts as a slaves. Mainly it is popular in mobiles. Next, another wireless technology is Wi-Fi. It is wireless fidelity, popular for again wireless communication. It's compared to Bluetooth. It's little bit developed technology. It supports for IP protocol. You can access the internet using Wi-Fi connections and using IP address. That's why it is known as IP protocol, and it is intermediate. It's called Wi-Fi router. You are going to connect Wi-Fi connection using the Wi-Fi routers. It supports different data rate speeds 1 Mbps to 150 Mbps. Offer range of 100 to 300 feet. Next, Zigbee is another low power, low cost wireless network protocol. It up to distance is it supports 100 meters and data rate is 250 kbps. Again, here three types of Zigbee device category: coordinator, router, device. If you want to have a Zigbee connections, the cost is also less, it consumes less power, and here coordinators act as a root of the network. Responsible for the coordinator is initiating the network, store the information of the network. Routers to pass the information from one device to another device. End device is for data communications. Example is smoke detectors, heating control and lighting controls. Next is general packet radio service, GPRS. Nowadays, if you want to have a network connection in your mobile, you can say that 2G, 3G, 4G. So first is start with the GPRS, that is general packet radio service, which is give the service for data as well as voice in the mobile communication network like a GSM, and it is going to send the data in terms of packets. After receiving the data, it is going to recombinate or reconstructed all these received packets, and finally you will get the messages. It mainly happens in the mobiles by using the radio channels. There will be several users can use the different radio channels and dedicated for the cell phone user. For that you have to pay for that to use those radio channels which are shared for different users. It mainly used for mobile enabled embedded devices. And finally is embedded firmware is nothing but embedded software. If you want to work with different embedded applications, you should have the embedded firmwares, which has you need high level languages to write the programs to make your system work in different speed with the efficiently effectively. For that you should know the different embedded softwares to write your programs. For that you need different requirements. You should have the good target processors, and you have to store the code in terms of hex file creations. And for beginner it's better to use HLL. You can make write the code is easier, highly portable, and it's not a developer dependent. But assembly language is a little bit tedious and time consuming, highly dependent on the developers. If you are writing program in embedded applications in the assembly language, you should know the assembly language which one you are using, and it takes some time to process, and it highly depend on the developers. And you need some other components like circuitous. You needed reset circuits to reset your systems, and to process and to control the execution of your program you should have the Browner protection circuits to avoid the data corruptions. It is very essential for battery power devices. And you need oscillator unit to responsible to generate the clocks. For the processors, it is going to measure speed of the processors. It mainly depends on the clock that is provided by the oscillator unit, and also depends on the clock frequency. You can determine the power consumptions, and execution speeds determine the accuracy. So you should have the good accuracy of the clock signals. There some real-time clocks that are going to used in the systems to keep the track of the time, and some of the embedded application going to run in real time. That's why you should have the real-time clock in our systems. This is available in form of ICs also. You can use those real-time clock ICs to maintain, and sometimes this comes with the OS kernel identify the interrupt, that is have a real-time clock. Next is watchdog timer. It's mainly known as to monitor firmware executions, and if it is not firmware execution not happened with a predefined time, so it is going to reset whole systems to avoid the corruption of your systems. To avoid that one, it is going to use some increment or decrement counters to monitor the firmware executions. Within that predefined time, it won't execute the firmwares. It is going to reset whole systems. Again, it is going to start from the reset operations. And finally, you need different PCBs. It is main important thing is you have to select a good way of PCBs, printed circuit boards, and it needs along with the PCBs, along with all these components, you need resistors, capacitors, and inductors with the different values to control the power, to control the current, to control the voltage in the PCBs. This is main components of your embedded systems. These are the important concept which is present or comes in the second unit, and concentrate all these concepts as the exam point of view. Prepare, and all these concept whatever I explained now is very useful for second unit, and as my exam point of view you will get total 30 marks on this one. And study well and solve the related all assignment questions. If you have any queries, come back to me. I will get the solution for those doubts. Okay, thanks, and thanks for watching these videos. All the best.